Hello there, this is Professor Watts coming at you from my home office. I want to just give you a brief rundown on how these tutorial videos are going to work for the Business Research and Decision Making course. Don't worry, you're not going to be looking at my ugly mug for the course of the videos. You're basically just going to be listening to my irritating voice as I voice over walking through problems in Excel by and large. Now this first video we're just going to jump right into homework problems in chapter 2 and 3 because it's hopefully stuff that you're really familiar with in terms of just working with data, descriptive statistics and that kind of thing. So I don't think it's worthwhile to do a separate lecture component. In later videos we will actually break it apart into a lecture component, what I call the tutorial, and then the homework component. So I'll lay some concepts out for you and explain things. We'll still run through some examples in Excel, but then we'll have a separate video where we walk through homework problems, do things together, and then I'll challenge you in those to work some problems all by yourself to kind of see if you've really learned it. These videos do tend to drag on because there's a lot of practice problems packed in. So I would encourage you to just pause when you finish a problem, come back later. Don't try to go through the whole thing all at once. And of course the benefit is that you can pause, rewind, review. You can watch at a slower or faster speed on YouTube. Depending on whether it's really clicking for you, you can speed it up, or if you're struggling a little bit, you can slow it down. Okay, and then I would also recommend to have two screens, whether you have two computers or a dual screen setup with your one computer. Be playing the video on screen 1 over here, and then on screen 2 over here have the homework file open in Excel to be following along, and then you can pause my video as you copy what I'm doing or slow the video down. So we basically can go one by one replicating what I'm doing in Excel, and that's really the best way you're going to learn the skills. Okay, so let's get started. You'll notice what I've done is I've just copied over the worksheets from each of the separate files that the book provides. The book has hundreds of Excel files, and I've picked the problems that are relevant for us. I've copied all the data sets into here, and we'll just work through problem by problem. So we have problems 2.3 through 2.36 for chapter 2, and then 3.28 through 3.4. I highlighted down here the worksheet tabs in yellow. Those are the ones you're all doing all by yourself. But like I said, I will have just walked you through the tools and the techniques that you'll need to do those. Problem 2.3. Okay, the file gives us data from a survey of 399 people regarding a government environmental policy. A, which of the variables in this data set are categorical? Which of these are nominal? Which are ordinal? Right? Well, let's work through and talk about those. We've got 1, 2, 3, 4, 5, 6, 7 variables. Person, that's just a count of persons 1 through 399. Age, it looks like we're doing middle age, young, and elderly. So we've got 3 different categories. That would make it a categorical variable. It's not in the assignment, it's not in the problem for us to convert this, but I think it's an important tool that I want to spend a minute showing you how to use. So to convert these numbers, to go from a range of numbers and to categorize those into what we call discrete bins, we use the VLOOKUP function. So first off, what we're going to do, we're going to tell Excel to scan these numbers here and then convert them into a word based on what range they fit into. And over off to the side here, we'll make what we call an age lookup table. And if it's between 0 and 35, we're going to have it label it young. If it's 35 to 65, we'll have it label it middle-aged. Above 60 is elderly. Okay, and then to do the VLOOKUP function, we need to have this as a reference. So we're going to create a new column by inserting in C. I'm going to tell it equals VLOOKUP, open parentheses. Now this is a little tricky, so bear with me. I'll show you how to do it for both converting ages into category labels and for converting the salaries, and we'll do like low, middle, high income with those. Okay, so first lookup value, that's what we want to, we're going to look up the age, that's a lookup value, and we're going to convert it into one of these category labels based on its value. So the lookup value is the number we want to look up and then convert. The table array is simply this down here, so we're going to tell it to look in the left column of their table array. Whatever number it's approximately closest to, replace it with the word on the right column. So that's the table array. Now, I do need to lock that because as I'm going to fill this formula all the way down the column, and I don't want it to slide down the table array references as well, so I'm going to lock it by saying $$15 and $$17. That'll tell Excel that when we're going down here, so when we slide down from column 2 to column 12, let's say we've slid down 10 rows, we're not going to slide our table array references down 10 rows as well. Notice there's nothing 10 rows down there. Okay, so we lock those with the $. And the $sign locks what you put it before. So we could, all we need to do here is lock before the row number. So $15 locks us into row 15. We could, the same thing would be accomplished if we locked column J, but we're not going to change column references at all, so that's kind of superfluous. But that's what the $sign does whenever you're working in Excel. That right there is an important thing you need to know, using the $sign to lock your cell references by column and row. Okay, so we got our table array in place, and now the column index number, that says of all the columns we've referred to, which one are we indexing, and it's going to be column 2. And then true or false, whether we want an approximate match or an exact match. Now, we'll go with an approximate match, and then what Excel will do, and we'll go ahead and hit enter. And notice I double clicked there to expand that column width to show the whole word. Okay, so that's how you convert numerical into categorical variables, VLOOKUP. Just remember the function. It's kind of a tricky one, and if you ever need to use it, you can maybe jump on the Microsoft tutorial or what have you. But in the problem we work, we'll have that all pre-done because we want to focus on doing some other things, such as summary statistics and whatnot. But anyway, just to wrap this up, hope you all are familiar with the fill function. But if you're not, let me just show you how to do that really quick, or the fill tool. So you click, once you've got a formula selected or a cell, you go down to the little green dot on the lower right corner until you get the black crosshairs, not the big plus sign, but the finer crosshairs. Click and hold your left mouse button and drag that down, and that copies. Okay, I've had a little problem there. I realized my mistake was that I needed to actually type the word true in to get it to approximate the value. So anyway, find the crosshair and then click and drag. There we go. And now it's going to categorize according to the value. So if it's between 0 and 35, it's going to label us young, like right here. If it's between 35 and 60, like right here, it's going to label us middle-aged. And above 60, it'll label us elderly. So let's fill that all the way down. We only want to fill this one. That's VLOOKUP converting numerical entries into categorical entries. Okay, so that's what we've done already. Let me go back to homework 1, and that's what we've done already. Okay, so going back to problem 2.3, which of the variables are categorical, which are nominal, which are ordinal? So to answer that, we might just go over here and put A and just type our answer in. Why is my text not showing? That's probably something with cell alignment. There's a couple of ways we could fix this. The easiest way would be to just make the column width match what's in it by double clicking like that. And by the way, to undo everything I'm doing to get me back to where I was, I'm just hitting Control Z. Okay. Another thing I could do is go to Format and Alignment. And it's on right alignment. That's why it's not showing me the whole thing. If I just put that on General Alignment, it'll let the text spill over into the next columns. So let's see. Categorical variables are age, gender, state, opinion, which are nominal. Nominal means that there's no natural ordering to the data. So, okay, with age, we could rank those oldest to youngest, so those could be ordered. Those are going to be ordinal, not nominal. Gender, there's no natural order. Doesn't matter if we put male first or female first, so those would be nominal. State, same thing, no natural ordering there, although I know all of you would want to put Texas first. But children, same thing. Actually, because children's numerical, that's not applicable. Salary's numerical, so this isn't applicable. And opinion, we could rate. We're going to order those from either strongly disagree up to strongly agree, or strongly agree down. So those two are the nominal. And again, let me just widen up the cell to show all of that. And then which are ordinal, age, salary, opinion, things that have an order, highest to lowest, what have you. Okay, so B says for each categorical variable, create a column chart of counts. So what I want to tell Excel to do is go through each categorical variable, so for age, and get a count of how many entries there are for middle-aged, how many entries there are for young, how many entries there are for elderly. How are we going to do that? Well, let's go over here, let's put B, and then we're going to create some placeholders for the categories young, middle, aged, and elderly. And I'm going to use Excel's COUNTIF function. Equals COUNTIF. And it tells you there's only, this is much more simple, there's only range and criteria. The range is the array of cells I want Excel to look at. So I'm going to select B2 to 400. Now clicking and dragging is one of the easiest ways, but once we get larger data sets that have hundreds of entries, it becomes really tedious to drag all the way down. So I'll show you next time how to do that much easier. We'll just type. And then criteria. Criteria is what I want it to count, starting off with young. A couple ways I could do that. I could just click on cell I8, close parentheses, or I could actually type it in with quotation marks. I'll show you the other way here. So for young, Excel scanned those cells over here and found 87 entries labeled young. So let's do middle age equals count if, open parentheses. The range now, we can just type it in. B2 colon B400. Okay, and then the criteria, quotation mark, middle dash aged, I want to make sure that matches exactly the same as what we're looking for. Close parentheses. Okay, so that's how I got my counts of that categorical variable. Now Excel wants me to make a column chart. Column charts are one of the easiest things to do. I'm just going to select this array over here, go to Insert, 2D column, bam. Change the name if I want, count by age. And that's, I could do some formatting here. I don't want to waste a lot of time on that right now. Let me drag this over here. Bada boom. Okay, we want to do that for each one. So which other categorical variables do we have? We have gender. Let's see the coding. If we click on the little red thing, there's a note there for us. 1 is male, 2 is female. So let's go down here and let's type in male and female, and then we'll do our counts over here. COUNTIF. My range now is C2 to C400, and my criteria is male was number 1, right? So my criteria is 1. Now check this out. I can fill this and then just edit it by replacing the 1 with the 2. Bingo. 1 is male, 2 is female, so that's correct. Okay, so using my COUNTIF formula, easily summarizing what I've got going on in these 399 entries over here. And to make my column chart, again, just select the array, including the labels, insert column chart. Okay, so we've got that. Let's slide that over here as well. Whoops. Just to get it out of the way of everything else I've done. And then we want to count by state. We're going to do all the categorical variables. State. How many different states do I have here? I don't know. Do I have all 50 of them? Boy, that would sure be a pain to make a new table over here with a count for each state. So, okay, so here I don't know how many different entries I have. So I want Excel first off just to tell me how many different unique entries I have. And this is totally out of the book, but I looked up what's a good way to do this. You can actually do it with a formula, which I'll show you. And then we'll also try to do it with a filter. So basically what I want Excel to do is tell me how many unique entries there are in this column of data. And what I found by just a little searching online is that you can use this formula here, sum product, and we're going to do 1 divided by a COUNTIF, and then the COUNTIF range is going to be D2 to D400, and the criteria is going to be D2 to D400. And don't ask me to tell you how this works. Excel auto-corrected it for me. It looks like I missed parenthesis, but it's telling me that there's 10 unique entries. And again, that's one I don't really understand, so I can't explain, but nonetheless we can use it. Okay, so I know there's 10 different things there. Another thing we could do is just select that column and then go to Data and sort A to Z. Now, if you don't have the whole, if you just select one column, Oftentimes Excel will tell you that you need to expand it, so to say okay. And then we'll see, now we can kind of go through and count, or at least we can come over here and make our list of things we need to count. Arizona occurs, California, Florida, Illinois, Michigan, Minnesota, New York, Ohio, Texas, and Virginia. And just to verify that there's 10 different entries here, let me just use the regular count function. Actually, we're going to have to use count A because we're looking at not just numbers, we're looking at text. So count A is a variation of count that's looking for things other than numbers. And indeed, yep, there's 10. Okay, so let's go back over here, and now let's just enter a count if function. Count if D2 to D400 is Arizona. Whoops, I need to put that in quotation marks. There we go, 33. Let's drag this down, and now I'm just going to click on that and replace Arizona with California. Oh, I got to lock my cell reference. D $2 to D $400. I often forget to do that, and then if I get a kind of a screwy result, that's one of the first things to look at, go back and fix it. Because what happens, remember, when you slide a formula down, it also slides the reference range down. So we got to use that $sign to lock that range. And here, because we're not going to be outside of column D, we don't need to lock column D. Although we could, as I've done before. It wouldn't hurt at all to lock column D, but we definitely need to lock the row values 2 to 400. Okay, now let me slide that formula down. And of course now we get 33 each time because it's looking in the exact same range, D2 to 400 for the value Arizona. But now we just replace the word Arizona with California. Whoop. Okay, I get 0. That's all. Well, I know I remember seeing it over there. So what did I do wrong? Probably just a stupid typo. And that's right, I spelled California. So be very careful with your typing. And California happens to come up 33 times as well, coincidentally. What about Florida? 41 times. What about Illinois? 38 times. What about Michigan? 46 times. What about Minnesota? Remember, not case sensitive. 31 times. New York, 46. Ohio, 44. Texas, 48. And finally, Virginia. Whoops. Okay, Virginia, it fixed it for me, 38. Okay, once again, making the column chart, select that array, insert, column chart. Let's go 3D this time, just for funsies. Okay, and now we'll title this count by state. And we could mess around with the formatting of this, but like I said, I want to move along, so let's just slide that over there. And that's part B. Moving on to part C. Okay, part C wants us to recode the data into a new data set, transforming some of these categorical data from numbers to words, or binning some of the data. So for instance, salary, we're going to group those into 4 categories. Opinion, we're going to replace the words with numbers that correspond on that 1 through 5 Likert scale. So how should we go about doing this? There's a few different things we could do here. We could cut and paste all this to a new sheet, or what I like to do is just kind of go side by side and make replace one column with another and then delete the original column. So I'll show you that method. What I'm going to do first off is insert some new columns, because what we're going to have to do using the VLOOKUP function is create lookup tables. And this is really tricky, so you want to watch very carefully and follow along here. So first off, it's asking us to convert gender from 1 and 2 to male and female. So first up, we're going to create over here a lookup table, and I'll call this gender lookup. We're going to have 1 be converted now to male and 2 to female. I'm going to put a new column in to the right of gender, so I insert it to the on the next column over. I click on the column heading up here and right click, select insert. And now I'm going to do a VLOOKUP function here. Okay, VLOOKUP. Lookup value, we're going to look up C2. I'm not locking that because as I fill this formula down, I want the lookup value to slide down with it. Okay, so it's C2. Table array is this lookup table we just created. That we do need to lock because that's going to stay fixed. We don't want that to slide down 1 row at a time as we slide this, as we fill the formula. So that has to stay fixed. at least with reference to the rows. Column index number is of our table array, or of kind of the reference table we made. What are we looking up, and then what are we replacing it with? We're looking up the numbers and we're replacing it with the words. The words are in column 2 of the table array, so I want to enter a 2 there to tell it to replace the number with the word. If I put a 1 there, it would keep it as a number, because the column 1 is the numbers. Okay, so I'm putting that for column 2. And then whether we want an approximate or exact match, this time we'll want an exact, so we'll enter the word false. When we bin the salaries into ranges, that one will do approximate. Okay, we'll get there in just a minute. Okay, then I'll fill that, and notice it's doing exactly what I want it to do. Let's fill it all the way down to row 400. Okay, so let's go and do the same thing with children. I'm going to insert a column next to children, and I'll make a little lookup table over here. I'll call it children lookup. And what it wants us to do is just categorize these into no children or at least one child. So if it's 0, I want it to replace it with the text no children. And if it's 1 or above, we're going to have at least one child as the text it enters to replace. Okay, a couple of ways we could do this. The children looks like it goes up to 3. Could be higher than that, of course. So I could put extra entries here, 2, 3, 4, 5, 6, and then copy down. I could fill in at least one child, you know, like this, and then use this whole thing here as my lookup table reference. That's kind of tedious, and I might make a mistake doing that. So let's just we'll use the approximate matching type. Let me put a heading in for that. We'll use the approximate matching in our VLOOKUP. So now we're going to VLOOKUP. We're looking up here. This is what we're looking for, and then we're going to replace it with something. What we're going to replace it from comes from this table array. And remember, we have to lock these so they don't slide when we fill the formula. Okay, column index number. That's again 2 because we're looking up numbers and replacing them with words, and the words are in column 2 of our reference thingy over here. So that's again going to be a 2. And then we're going to do approximate match, so we're going to type in true. And let's see what happens. Okay, that did what we would expect for 0. It says no children. When I fill it down, and let me double click to widen that column out, at least one child. 2 is at least one child. Hey, it looks like we're doing it good. Alright, so I'm feeling good. Now I'm going to fill this all the way down. Notice I'm not going to fill all the way down until I'm sure the formula is working correctly, because otherwise I'd have to drag and delete a whole thing. So there's VLOOKUP, a very powerful tool. In fact, the books in chapter 2 says VLOOKUP. It says there's arguably no more important Excel function than VLOOKUP, so you should definitely learn how to use it. Well, that's what we're doing now. Okay, so we've converted children. Now let's convert salary. This is going to be a little tricky because we're converting this to these ranges. Let me insert a side-by-side column. Go ahead and put the heading in. Salary, and now we need to make a new lookup table. Salary lookup over here. And what are we going to do? Well, if I just put a 0 here, the text it wants us to use is less than $40K. And then a 40,000, and this is going to be titled 40K to 70K. The book says between 40K and 70K. That's good enough for me. This one's going to be 70,000, and then we're going to have 70K to 100K, and then 100,000, and this is going to be 100K and up. Greater than 100K is what the book wants. Okay, let's do what the book wants. Greater than 100K. You'll notice that when we use VLOOKUP and we use approximate matching, it's going to automatically kind of do a less than or equal to function. Let me show you what I mean by that. So VLOOKUP, I'm looking up this. Here's my array. Gotta lock those values, people. Let's just lock the whole thing. Column index number, again, 2. And now true to give us the approximate match, and let's see if it does what we want it to. This one here is 48,000 and it's putting it into 40K to 70K. So basically what Excel's doing is saying, is it approximately 0, which would mean it's less than 40K because that's the next category up. So if it's less than 40K, Excel's going to basically round it to 0 and give us this text. If it's between 40 and 70K, Excel's going to say it's approximately 40K and give us this text. If it's 70 to 100, Excel's going to round it down to this and give us this text, so on and so forth. So let's see, and let's fill down. Here's one where it's greater than 100. Yep, and it's doing exactly what we want it to do. Okay, so now I can confidently fill this one all the way down. And now just one more, opinion. And hopefully we're getting the swing of things by now. I'm going to make a little lookup table over here, opinion lookup. Strongly disagree, disagree, neutral. That was a fat thumb mistake right there. Agree. Now this is neutral. This is neutral. Agree. Strongly agree. We want to convert those back to numbers. 1, 2, 3, 4, 5. It's going to be pretty much the exact same procedure we've already done with our VLOOKUP. That's our lookup value. Our table array is this. Lock those row values with the $sign. Like I said, that's one of your most important, most useful Excel tricks you might learn in the whole thing here. Column index, again, because we're going from text to number now. Numbers are in column 2, so it's going to be 2 again. And then here we can go with an exact match, so we'll type in false, close it, parentheses, and enter. So disagree is 2, that's what it's supposed to be. Agree is 4, that's right. Here's a neutral, that's 3, yep, okay, bada boom, that's all good. So let's fill that all the way down. If you just do this much, that'll be fine. Although, as I mentioned, technically to really convert this, we would want to get rid of the originals. And because if I just delete the originals, all of my cell references won't have anything to refer to anymore, so they'll turn into this #ref error. So I can't do that. To keep this data, I would want to copy and then paste values. That's one with the little numbers. And then I could delete the previous 2. Actually, I want to select it and delete. That'll get rid of those columns. Okay. Same thing here with salary. I can insert. Whoops. I only want to insert 1. Let me select 1. Label that salary. Copy this and then paste values. Now I can delete these 2. Insert. I don't even need to do that. I can just copy this. Paste values. Get rid of those. And then gender. I'm going to insert a new column here. Copy this. Paste values. Get rid of those. Delete. There. And I've converted it with no extraneous junk. And actually, because I'm done with my lookup tables too, I can delete all that stuff. Get rid of all these intervening columns here. And now I'm back to the stuff I'd originally done. Although, notice that here, male and female, because I got rid of that, converted it to text rather than number. I've kind of screwed up my count ifs. I could go fix those. I could say, I could use a count if range being now C2 to C400 and criteria male. And the same thing here. Let me just hit escape. Let me just fill this, and then type in female there. Okay. So you want to be careful there to note that if you have cell formulas with cell references and then you delete stuff, you might lose some of your output of your formulas. Okay. But fortunately, I maintained all of my column charts and everything else. And I know problem 2.3 was a lot to lay on you, but hopefully this will get a little bit easier. We'll get a little smoother. We've got a file that says it contains data on 148 houses that were recently sold in a fictional suburban community. The data set includes the selling price of each house, along with its appraised value, square footage, number of bedrooms, and number of bathrooms. First off, it says, it just wants us to understand the variables. A says which of these variables are continuous, which are discrete. So let's do that like we did before, and just type in our answers up here. Continuous variables, colon. Now continuous can take on any number of values. And appraised value, now we could go down to the penny, so it's technically discrete because we can't have infinitesimal fractions of a dollar and actual transactions, but we're going to treat this as a continuous variable. So value definitely is. Price, same thing, they're both in dollars. Square feet, I think for most mathematical purposes, I think we could go ahead and treat this as continuous, even though it's technically not. Again, bedrooms and bathrooms, we're going to treat those as discrete. Okay, those can only take on its kind of integral values, 1, 2, 3, 4, etc. If you're Bill Gates, it's 72.
As long as I've got my health and my millions of dollars and my gold house and my rocket car, I don't need anything else.
Okay, so we just want to understand the difference between those two variable types, just continuous and discrete. So that was easy. Moving on. B, create histograms for the appraised values and selling prices of the houses. How are these two distributions similar? How are they different? Okay, histograms. Histograms are very useful and a little tricky, and there's a lot of extra steps involved, so let me walk you through this very carefully. First off, to do histograms, now the textbook wants us to use a third-party software called StatTools, which is really slick, and it would be nice, but we just don't want to spring for it. It's extra cost and it's an extra kind of hassle. Fortunately, we can do pretty much everything the book's going to do with its fancy pants third-party stuff, with stuff that's available within Excel. Although you do need to make sure you have an add-in for data analysis. So I'm in Excel 2013 right here. I'll show you how to get your add-in. You want to go to File and Options. Okay, Excel Options, and then click on Add-ins here, and then down at the bottom, Manage Excel Add-ins. Go. Yeah, here we go. I got it all set up. So you click on Analysis Toolback. You hit OK. If you have it, it won't do anything. If you don't, it'll install it for you. And that's going to be really important for us in making histograms. Okay, histogram. In a histogram, if you don't know what it is, I could sit here and define it for you, but you're going to see in about 2 minutes once we make one. So let's just go ahead and make it. For the appraised value and selling price. A histogram is going to break these values down into categories and then graph them, basically, if you don't know what it is. So first off, before I can create the histogram, I need to tell Excel the categories or bins that I want. Now, I've got a whole bunch of values here, 148 values, and the question is, what bins should I use? Well, before I do anything else, I kind of want to get a sense of the range I'm dealing with. So I'm going to put a few labels in here, min and max, and I'm going to tell Excel, using the min function, to find for me the minimum of all of these values. It's 101,930, okay? And the max, using the max function. And I don't like clicking and dragging because that takes too long, so I'm going to use B2 to B149. Okay, so my values are all between 101,000 and 167,000. So I'm thinking it might be good to, let's say, start at 100,000. I'm going to label this bins, 100,000. And I think going by $10,000 intervals would be about right for us. 120,000, 130,000, 140,000, 150,000, 160,000, 170,000. And then what Excel is going to do in a histogram is find out how many of these values lie between 100 and 110, and then write the number down, and then also graph it for us. How many between 110 and 120, 120, 30, 140, 150, etc. Okay, so that's the only kind of extra step you need to do to do a histogram. So to do the histogram, we'll go to Data, Analysis, way over here. Click on Histogram, hit OK. Input range, and I've actually already done this earlier. I was making sure I knew what I was doing, but let me re-show you. It's the same B2 to 149. You can either click and drag or you can type in. Typing in is much faster. And then the bin range. The bin range, a little easier to click and drag this since it's not so large, is the bin's values I created. Okay. Now, and we'll check mark on the labels. We want labels on our histogram. Check mark down here on chart output. The histogram is the chart, so we want that. And where do we want it to put it? Let's just select over here, output range, a cell, and it'll display it starting in this cell. Okay, so I clicked cell I5 for my output range. I'm going to hit OK. And bada bing, here's my histogram table, and then here's my histogram graph. Let me just walk you through briefly what's going on here. So what Excel's doing is going between 100,000 and 110,000, saying how many of these appraised values were in that range, and 7 of them were. And then over here it's graphing that. The height of this column is 7. How many were between 110 and 120? 21. It's graphing it here. How many were between 120 and 130? 36. Yada, yada, yada. Okay. Now I want to relabel this because it's a histogram, but a histogram of what? I know it's a histogram, by the way, so let's just type in a new label, a new title, appraised values. Okay, let's do a histogram for selling price. I'm going to insert another column here to set up my bins, but I need to know my range again. So now I could go in and retype my formulas here, but it's the same range, so why don't I just select these, drag them all the way over, delete this. This stuff is irrelevant. Now I know my range on column D, which is my selling price, goes from 83,000 to 170,000. So I'll start my bins at 80,000 and work up to maybe 180. Okay, now this is not a whole lot of typing, but I don't want to sit here and type all these numbers. I want to increase it by $10,000 increments. So how can I do that? How can I do that? Well, I'm just going to select equals that plus 10,000, and then I'm going to fill that down until I get to where I want. Okay, that's a little shortcut there that makes things faster for you, especially when you have multiple numbers to enter. All right, now I'm ready for my histogram. Data, analysis, histograms. Okay, input range. Let's try that again. Easy thing to do here is to replace the B's with D's. And the bin range, I'm going to bin range. I'm going to replace the C's with E's. But it's not E to E9, it's now to E12. Output range, let's go ahead and manually select that down here. J16, let's say. And I want a chart, I want labels. Alright, I'm all set, so I'll hit OK. And voila, there's my histogram. Let's change the title to selling prices. I know that that's frequency in a histogram, so I can delete that. Okay, and then there's my histograms. Okay, and the book problem says, how are the distributions similar? How are they different? Well, it looks like the central tendency of appraisals is about in the 140 range, and that's the central tendency of selling prices. So it looks like as far as central tendencies are concerned, the appraisals are pretty right on. Okay, but anyway, let's move on. Find the maximum and minimum sizes of all sample houses. Hey, we've already used max and min to help us set up our histogram, so that'll be easy. And really, I'll just keep on dragging my max min formulas over. Now, I'm down here, though, and I can't remember what these columns are. So let me show you another trick that is helpful when you've got a lot of rows worth of data, and the headings are up here, but you can't remember what they are. What we're going to do is something called a split cells. I'm going to select a range that is right under my column labels, column headings, and right next to my row. And I'm going to go to View and select Split. Okay. And if you select a rectangular area, it gives you both a horizontal split and a vertical split. We really only need the vertical split, so I can select this part of the split and slide it over to get rid of it. And now when I scroll down, notice it's going to keep this, what's above the split, it's going to keep it up there. So I can scroll down to the bottom here. Okay, I know this is bedrooms and bathrooms. I know I've got my min max, and I'm just going to fill these formulas all the way over to save myself time. I don't care about the min max of the bin, so I'll delete those. I don't care about the min max in the bedrooms. I've got a little formatting problem here because my min and max on value and selling price are in dollars. It kept that formatting. Let me go up and change that formatting really quick just to basic numbers. I don't need decimal points, so let me get rid of them. Okay, so my range on square footage is from 1,200 to 2,500 square feet. Maximum min, that's pretty easy. That's part C. Now part D, find the houses at the 80th percentile of all sample houses with respect to appraised value. Find the house at the 80th percentile of all sample houses with respect to selling price. And we're going to work percentiles here. Hopefully you're familiar with how percentiles work. The 80th percentile would mean that 80% of the houses if we're looking at value, that would mean that 80% of the houses are at or below that value. Okay, you're probably familiar with these from your test scores, your standardized test scores, or your weight and height. We take our kids into the doctor, for instance, and my one son has a huge head, so my doctor said, yeah, he's in the 99th percentile for head size. Okay, his head's bigger than 99% of kids his age.
Well, let's have a look at the replay. William, move your head. Look at the size of that boy's head. Shh. I'm not kidding, it's like an orange on a toothpick.
So we all know how percentiles work, and it's very easy to calculate them in Excel. So let's put another label in here, 80th percentile. And for appraised value, it's just this easy, equals percentile. Now, there's two formulas that Excel offers, exclusive and inclusive. And we'll run them both. I'll show you that there's not that big of a difference, and I don't think it matters that much which one you use, as long as you're consistent in using the same one. We'll go ahead and do percentile exclusive. The two arguments in the formula are just the array. The array is B2 to B149. Now the K, which is the kth percentile, 0.8 for the 80th percentile. Notice if you enter 80 here, you're going to get an error. Percentiles are percents. You can't enter a value greater than 1. It's got to be 0.80. 0.8 would be just fine. And it tells us that value is 142,888. Let's try percentile. Let's try the other formula, inclusive. The array again is B2 to B149. And again, it's 0.8, 142,718. The difference in the formulas is really just it's really arcane math. And going with the inclusive one will be totally sufficient. So I'm just going to delete that one. Okay, so we'll go with percentile inclusive, and I'll move this down here. Okay, so there's our percentile. Now, that's all it's asking us to calculate, and to calculate the one on selling price, I'll just drag my formula over, delete that. So there's my 80th percentile on selling price. So that means 80% of the houses sold for a price of $145,000 or below. 80% of the houses appraised at $142,700 or below. While we're on percentile, let me quickly show you a few other things that are related. Quartiles. We want to calculate quartiles, which are percentiles grouped in fourths. So the 5th percentile, the 50th percentile, the 75th percentile. So if I do quartiles 1, 2, and 3, it's really the same as percentile with the K equals 25. And I'll show you that here. Actually, there's a quartile function. We'll use inclusive. And the array is still B2 to B149. And the quartile is 1. Let's format that as money with no decimal places. To show you that we'd get the exact same result with 25th percentile. Let's do percentile inclusive. Array B2 149. Okay, value 0.25. And again, let's format that to money with no decimal places. Okay, so the first quartile is a 25th percentile. Now to calculate the remaining quartiles, I'm going to lock my array $signs. I'm going to drag, and I'm going to replace 1 with 2 here for the second quartile. I'm going to replace 1 with 3 here for the third quartile. What's the fourth quartile? That's just the max. And I don't know if Excel, let's see if Excel will do that if I enter 4. So if I enter 4, that, notice, matches that. Okay, so there's doing quartiles. It's just as easy as doing percentiles. And I could also drag these over here to do the quartiles on selling prices. Delete this stuff. Okay, so now there's my quartiles on selling prices. Quartiles on appraised values, 80th percentile, or whatever percentile I want. You know, if I wanted the 99th percentile, for instance. Just a matter of filling and replacing one key value. We're going to replace the 0.8 with 0.99. And then I'm going to fill this here for the selling price and replace the 0.8 with the 0.99. Okay, so there's my 99th percentiles. Okay, so that's D. Finally, E, what are the typical number of bedrooms and bathrooms in this set of houses? Bedrooms and bathrooms. How should we calculate that? Let me insert a column here so I can put some labels down below. And the labels I'm going to put down here are mean, median, mode. And we're going to calculate some basic descriptive statistics. I'm going to underline this too so I can separate the initial data from the summary measures I'm doing. Mean in Excel, I hope you know, is just average. And here we're doing H2 to H149. And actually, let's just do H2 to H149. So on average, we've got pretty close to 3 bedrooms and pretty close to 3 bathrooms. Median is the value in the middle, as I hope you all also know, and I hope you're familiar with doing this in Excel. H2 to H149, the value in the middle of the distribution. 3, why has it got dollar signs? I don't know. Let's take that out of dollar and just put it in number formatting. Let's slide that over, and it's 3 for bathrooms as well. And finally, the mode equals mode H2 to H149. Again, that's somehow formatted as dollars. Let's just make it numbers. Okay, so these are very close to 3.03, 3.04. So I would say that all of our measures of central tendency give us the same answer. They basically give us 3. So we could safely say then 3 is the typical number of bedrooms, 3 is the typical number of bathrooms. Let's look at one more thing here, because problem 216, and you'll notice the ones highlighted down here in yellow are the ones you're doing completely on your own, is going to ask you to do one more thing than we've done here, and that's just standard deviation. And I might talk more eventually about kind of what interpreting standard deviation and the normal distribution and all that fun stuff, but let me just quickly show you how to calculate it in Excel. It's very easy. Equals standard deviation. Dot P or dot S depends on whether you're working with a population or a sample. Here it probably doesn't matter too much. Let's assume this is a population, because realtors probably could get access to all of the sales within a given time period, so they don't need to sample. And then just the same thing with the range, H2 to 149. So our standard deviation here, and we can report this maybe as 3 decimal points. We can fill. Okay, so our standard deviation is a little bit larger for bathrooms and bedrooms, and we built histograms of those and try to figure out whether they're normally distributed or not, and then the standard deviation will have some interpretive content for us. But for now, I just want us to know how to calculate it, and it's just that easy. Okay, so these are your really easy Excel formulas. I hope all of you have done these before. If not, I hope you find it easy enough. What's a little trickier is setting up bin values, which of course, remember, we had to find min and max and kind of figure out the bin sizes in order to use the analysis add-in and generate histograms. Okay, so let's move on to problem 220. And this one's going to be really easy, a little change of pace. And this is, again, I hope something you've done before. In the book, the problem says the Consumer Confidence Index, CCI, attempts to measure people's feelings about general business conditions, employment opportunities, and their own income prospects. Monthly average values of the CCI are listed in the file, which I've copied in here on the tab 220. A, create a time series graph of CCI values. One cool thing about Excel is making charts and graphs is so easy, it's so intuitive. So all we really need to do is click and select the labels and the values, and then go up to insert. Now we want a line chart, 2D, and there it is. Now if you're working with a lot with charts, formatting becomes important, but this is really all you need. So let's put a proper title on it. First off, Consumer Confidence Index. Value would be the title of that, something like that. Okay, and you can change formatting, font size, everything else, but again, we won't work on that. Okay, finally for today, we're moving on to problem 236, and in this problem, we're going to apply the tables tool, which is a really powerful, really fun, really cool tool, and there's so much you can do with this. We'll only do just a little bit, but I want to get our feet wet and get us familiar with it. So the problem says, The supermarket transactions file, which I've copied in here, P236, contains over 14,000 transactions made by supermarket customers over a period of approximately 2 years. Use Excel filters to answer the following questions. Okay, first off, before we can use the filters, we have to convert this thing into a table. So what I want to do is go up to Insert Table. And the data in this, if you, it starts at A1 and it goes all the way to O14060, which I've typed in here. My table has headers. That means that the first row is not variables, but it's labels for the column. So I click OK, and Excel has done something very cool for us. It's turned this into a table where now we have a drop-down menu. We can do all kinds of sorting and filtering based on each column. Now we can also, before we do any of that, we can go to the very bottom and we can select up here Table Design and select this total row, and then that'll allow us to do all kinds of fun stuff to summarize the values in each table. So most of these are categorical and not numerical, but let's go to something that is numerical. For instance, over here, the revenue from each sale, and click on this little arrow drop-down menu. We can get the average sale. We can get a count of how many there were, 14,059. We can get a max, a min, sum. So let's just leave that at average. And then we can do that uniquely for each column in the table. So for instance, for number of children, I could do maximum, while over here for revenue, I'm doing average. Okay, units sold. Let's say we want the sum. We sold 57,000 units. So for each column, you can do something. You can do some kind of unique summation or average of the values in that column. Okay, so we have those two things set up. That we've created it into a table, and we've put the total row down at the bottom. Now, let's tackle the things the question's telling us to do. The problem. A, what proportion of these transactions are made by customers who are married? So we want to go to marital status, and there's a couple ways to do this, but I think the easiest one is to click off Select All and then click on Married, and for married, click OK. And what it's going to do is it's going to actually it's going to hide or remove from view all the entries for singles. So if I scroll down to the bottom and now to my total thing, I'll just put count, and that tells me that there's 6,866 entries of married people. So if I want to create a proportion, I'll just do this, equals that value divided by the count of the whole data set, which is 14,059. And I'll format that as a percent. You can do that easily right here when I right click. So my answer for A is 49%. And I'm going to go ahead and write these down here because we might lose that when we do our next sort. So A is 49%. B asks us what proportion of these transactions are made by customers who do not own a home. So now we don't care about marital status, so I'm going to go back to selecting all there. And I'm going to go to homeowner, click select all, and now hit no. And now all I have to do at the total here is account on the non-homeowners. And now my percent for notice my percent in D in the married single column is counting the number of non-homeowners. It's going to be the same for every column because I'm sorting on non-homeowners and I'm taking away everyone else regardless of the other entries. So my proportion now is 40%. And you'll see that if I slide that over, it's the same. Okay, easy, right? C. What proportion of these transactions are made by customers who have at least one child? Let's go up, unfilter on homeowners. So we'll go back to select all there. And then it says customers who have at least one child. Now I'm going to unselect select all, and I'm going to select 1, 2, 3, 4, and 5. So this is 1 or greater. And my count, let's do a count here, is 12,715. And that's the count for everything else, and so my percentage is 90%. Okay, and then finally D, what proportion of these supermarket customers are single and own a home? Now we're going to do a multiple filter. So I'm going to I'm going to undo the children filter. It says customers who are single and own a home. So let's first select only singles. And then in addition, and you'll notice that if I'm filtering here, you'll see the little funnel icon in that drop down. That means I have a filter employed in here. And if I keep that and then go over to homeowner and select only Y for yes, now I'm doing a multi-filter. So I'm filtering unmarital status and homeowner together. And my count of them is 3297 or 23%. So I can enter 23% for my answer right here. Okay, that's tables. I think we'll come back and use tables quite a bit more. Very powerful. We're all in on a kind of related topic of pivot tables, which are going to be the ultimate kind of in what Excel can do with this kind of array of data. But we'll come back to that another day. And we'll take a break now, and we'll come back soon and work the Chapter 3 problems.